Hey, Math 1. This is probably the last notes you'll get during quarantine for me, and maybe the last notes of Chapter 6. We'll see. We might look at some story problems that lead to systems of equations, but this is probably the last basically new thing, and it's not going to take long, I don't think. So let's get started. Here we go. So this is going to be notes for section 6.5. Be a little taller. There we go. All right. Guess not. I guess shorter is a little better. Okay. So the goal here is to determine if a system of linear equations has one of three things, right? No solution, one solution, or infinitely many solutions. And let's get to it. So when we solve a system of equations by the graphing method, I actually showed you this when we did the graphing method, we should know from the graph whether there is no solution, one solution, or infinitely many solutions. And that is based on how many points the two lines have in common. That is how many solutions there are. So if you have a graph where you graph the two lines and they cross, right? That would tell you that there's one solution to that system. We already knew that. If you graph your two lines and they are parallel to each other, that tells you that there is no solution to that system. And the last one that's a little bit confusing is you graph the two lines and they turn out to be the same line, one right on top of the other. So if they're the same line, that tells you that there's infinitely many solutions. Notice that that is not all solutions, it's infinitely many. Any point that is on the line would be a solution, but points not on the line would not be a solution. So it's not all solutions, but it is infinitely many solutions. All right, that's something we already knew from the graphing method, I'm hoping. What about if you're using the substitution method or the elimination method? Well, now you can tell, and I think I went over this in the substitution method, because the variables both end up canceling out. Like if you were doing the elimination method, and you had 2x plus 3y equals 10, and negative 2x minus 3y equals 24, and you added those equations together, both variables would cancel out. So you'd be left with 0. No variable at all, just 0. And over here you would have 34, right? Or maybe you're doing the substitution method, and when you substitute, you get something like 2 times 3x minus 6x plus 10 equals 10. So you've done the substitution, and now you go to solve it, and you get 6x minus 6x plus 10, and you say, oh, it cancels out of the problem, and I'm left with 10 equals 10. Right? So in both these cases, both variables end up canceling out. And you're left with simply numbers. And I think you know at this point, but if the numbers are equal, then it means infinitely many solutions. And if the numbers are not equal, it means no solution. But we'd like to do something different today. We'd like to save all this work, not have to graph it, not have to go through all the elimination and substitution method. Today, we want to look, we're going to see how to tell if the, okay, let me start again. We are going to see how to tell the number of solutions just by looking at the system. And maybe doing a tiny bit of mental math. But we'd like to do this without doing really any work. And so here's how you might tell. So first up, what if one entire equation is a multiple of the other equation? For example, you have 2x plus 3y equals 9, and you have 8x plus 12y equals 36. So what we're looking at here is the variables and the numbers separately. See how the x's are multiplied times 4. See how the y's are multiplied times 4. And see how the numbers are multiplied times 4. So one entire equation is a multiple of the other equation. This first equation is just multiplied by 4 to get the second equation. In this situation, there are infinitely many solutions. These two equations are actually the same equation. If you graph them, they would be the same line. Taking an equation and multiplying it by 4 or any number does not change the equation. So because they're actually the same equation, there's infinitely many solutions. Let's go to the back. What about both variables are the same multiple of each other, but not the numbers? And I could do a similar example to the one I just did. 2x plus 3y equals 9, and 8x plus 12y equals 15. Alright, so again, it seems like here, for the x's, I can multiply by 4. For the y's, I can multiply by 4. So the x's and y's, same multiple, but not multiplied by 4. The numbers are not multiplied by 4. So both variables are the same multiple, but the numbers are not. This situation means there is no solution. These two lines would be parallel to each other if I were to graph them, but they would not, right, they'd be parallel to each other, so they'd have no point in common. That's why there's no solution. And then our last case is each variable is a different multiple. Like 2x plus 3y equals 9, and 8x plus 6y equals whatever, it doesn't matter, 18. So the x's are multiplied by 4, but the y's are multiplied by 2. So the variables are not the same multiple from one equation to the other. Not the same multiple. First equation times 4 for the x's, first equation times 2 for the y's. So each variable is a different multiple. This situation means there is one solution. if I were to graph these lines, these two equations, they would be lines that cross. All right, we're going to practice this for 2 or 3 minutes, and we're going to be done. So this is what your homework is going to look like on Delta Math. You are going to be given equations, and it's going to be multiple choice. You got to decide if there are no solutions, one solution, or infinitely many solutions. So let's see. So here it looks like I am multiplying by -1. Here it looks like I am, right? +1. If I multiplied +1 by -1, I'd get -1. And here it looks like we're multiplying by -1. So the entire first equation can be multiplied by -1 to get the second equation. That is infinitely many solutions. What about this one? Looks like I am multiplying by 5. Looks like I am multiplying by 5, but this one is not 5. So this would be an example of both variables are multiples, same multiple, but the number is not. That means no solution. See how quick you can do this without doing any work practically? Looks like this one is the first equation is multiplied by -2. But here the first equation is the same, so it's multiplied by 1. The variables are different. That means that there is one solution. These lines would cross. Number 4. What are we multiplying by here? -1 times what is -5? Well, that's 5. 2 times what is 4? That's 2. Oh, the variables are different. That is also one solution. How about number 5? Looks like the x's are multiplied by -5. 1 times -5. Looks like the y's are multiplied by -5. Looks like the number is multiplied by -5. So the entire first equation can be multiplied by -5. That is infinitely many solutions. And finally, let's see. Looks like this one is multiplied by 2. -3 times 2 is -6. Looks like this one is multiplied by 2. 1 times 2 is 2. But this one is not 2. So when the variables are both multiples but the number is not, that means there's no solution. These are parallel lines. All right, that's the new thing on the homework, plus we'll do a little review on it. Good luck, and I will see you guys Friday.